I'm Jovan. I'll be here as a tech support during the tutorial. I want to introduce you to our tutor, Ved Prakash. He's a staff data engineer at GitLab, and he will hold the Supercharge your real-time analytics, Snowpipe streaming, and dynamic tables in Snowflake tutorial. Enjoy.
Thanks for that. Hello, everyone. Please let me know if it is not audible or the screen is not visible. I will start. So, hi, good evening, good afternoon to people across the Serbia and across the Europe, and from wherever you're joining. Hi, this is Ved Prakash, and I work as a staff data engineer at GitLab. Today, we are gonna talk about and learn about a little bit around something new which I discovered myself. That is a Snowpipe streaming. I used to use extensively Snowpipe, but this is something new, which is Snowpipe streaming, which came up, which got GA recently in the month of June. In the Snowflake Summit, they announced it, and the combination of it with the dynamic civil. So I thought, like, this is something which makes a real-time analytics a very enthusiastic and really meaningful. So with this, we start. So as we start, just wanted to set up like few ground rules. The duration will be approx 60 minutes plus 15 minutes for break. If we are tired up and exhausted, please let me know. 10 minutes for Q&A session. For noise, please be muted by default. If any question, please put it on chat and then we can take it async. Question answer, if you want to stop me and ask a question during the class, feel free to drop us question in the chat window at any time. All the resources for the tutorial is present in the link over here. I will just share it also in the chat in case someone needs to get access, but I'll share it across at the end as well. So with this, let me just pull out the tutorial link, if that's helpful. I just put it in the chat window just for references, for the code snippets, and for everything. It's a mix of all. And just the last part, do not forget to enjoy the demo. So with this, let's kick in to this. So meet your host, that's me. I'm staff data engineer at GitLab. I've been working for over 15 years in data engineering, specialized in cloud compute, cloud platform like GCP, AWS, and Snowflake. Programming primarily on Python and Spark, PySpark, and tools like Terraform, dbt, and Monte Carlo. So been working on leading product developments, mostly data products for the supermarket chains in UK and US. Has been a data engineering lifecycle from right from the planning, pipeline design to design right from the beginning to the very end. Collaborate in a very collaborative setting, more mentoring teams and creatively solving complex problems to drive impactful business decisions. So I've been at GitLab close to now 4 years and taken care of the data platform infrastructure, mostly focused on scalability and reliability and resilience of the data pipeline. Before that, have been on with Infosys London for 11 years, working for one of the London-based client, building successful data products. So I've been very confident. So my journey of Infosys, I started with the two of the best technology. I think I had confidence in Oracle database and Unix scripting, and that's where I started a decade before as a system engineer. And I was there. The data engineering move in this last 10 years or 12 years, the data engineering moved from the back seat to the very front seat, and now we have of the front seat in this whole leading world of AI, what we are having. So from here, let's is hope that in the next 1 hour you enjoy something, you find something useful and take a meaningful experience with you today. So the next is the agenda. To briefly touch it upon, we'll talk about introduction to Snowflake, just to give a brief overview, architectural overview and key concept around Snowflake, Snowpipe streaming deep dive. We'll take a break, 10-15 minutes. We'll After the Snowpipe streaming setup, I will just check the chat. If people are tired and exhausted, please put for a break and we'll do for a break. Dynamic table overview, how both Snowpipe and uh, dynamic table work together, best practices and use cases, and finally the questions. With this, we proceed with the what introduction to Snowflake. So what is a Snowflake? That's a very question, right? It is a cloud-based solution everyone have used to, coming traditionally from the on-premise system like Oracle, Netezza, and all, even DB2 mainframe. I'm not sure people have used it, are using it recently, but yes, those are the old legacy database system and application what people used to use. So Snowflake is developed in 2012, is a fully managed SaaS software that provides a single platform for data warehousing, data lakes, data engineering, data science, all data application development, and secure sharing and computation for real time. So Snowflake features out of the box features like separation of storage, query processing, and the service layer. So this diagram which you see, it's like one of the unique thing which came up when I first saw the Snowflake. It was new to me back in 2016 that they had a very different approach for this database where they separated the storage with the compute, and not just compute storage, but also they had a different service layer which was taking care of the whole of the administrative pain point, what most of the DBAs in the older world were struggling about. So it was one platform, one entry, one UI from where you can do everything, whatever you want to do. So that is for me is a high level of Snowflake. And on the architectural overview, to give the Snowflake, so Snowflake Data Cloud is powered by an advanced data platform provided by a self-managed service, right? Snowflake enable data storage, processing, analytics solution that are faster, easier to use, and far more flexible than traditional offering. So what's the Snowflake architecture is designed? Is designed as scalable. So the core design of the architecture around the Snowflake is that it provides a scalability, flexibility, high performance. No. So if you look at that in the storage layer, right? So it has a database store layer that sits in the center. So that's the centralized storage for all data. Automatically manage the data distribution and optimizations, supports various data formats. So the storage layer contains both structured, semi-structured, unstructured data. Query processing layer, that is compute. So that sits on top of the storage layer. And that is again a separation between the storage and the compute, where we have a virtual warehouse for executing queries, scalable and independent of storage. So there is a high scalability in terms of compute sharing. If there is a team of data analysts of marketing and there is a team of data analysts for sales, and they both want to talk to use the same data sitting in the Snowflake, we will not have a problem of a noisy river in this world, where you can have a dedicated compute for data analysts for marketing, and you have a dedicated warehouse or dedicated compute for data analysts for sales. So if either of the team analysts are running very heavy query, trying to query the same data set at the same point of time, they don't get this performance problem. So that's what is the scalable and independent of storage. They have the compute layer which sits on. Then they have this cloud service layer, which manage the metadata, security, and overall system coordination. So it handles the authentication, access control, and query optimization as well. So that's the whole service layer, they call it. On top of that, it comes with the client connectivity, which supports the various client interface like ODBC, JDBC, Python, Golang driver. You have a web-based UI for administration and query execution as well. You have a SnowSQL. So these are like four different in the terms of architecture, the storage, compute, and the service. That's what the key feature, just to reiterate, is that separation of a storage and compute, automatic scaling, and performance optimization, and multi-cluster shared data architecture. So taking it a little further, so a Snowpipe. So I talked about a Snowpipe streaming, right? But before a Snowpipe streaming, when a Snowflake came, they came up with the very powerful feature called a Snowpipe, and that used to enable the continuous automatic loading of data into Snowflake tables. And a Snowpipe enable loading from files as soon as they are available in the stage. This means that you can load data from files into micro batches, making it available to the user within a minute, rather than manually executing a copy statement on a schedule to load larger batches. The, this was one of the features before this Snowpipe streaming came, that that was the maximum within a minute latency. That's the requirement what they had, that the file arrives in an external stage like S3 in this example, if you see in the diagram, or GCS bucket or Azure data, Azure blob storage. From there, it is a sense that as soon as the file arrives, it sends an SQS message to Snowpipe saying that the file has arrived, and and then the Snowpipe is responsible to copy that file into Snowflake database. But this had a lag. It's like it is very close to real time, but it's not a real time. It's not, do not work on the streaming data set, right? It has a batching thing which happens. So that's where they introduced like the concept of Snowpipe streaming. Okay. And as you see in this diagram, right, both goes to the same table in this target, like a staging table. But if you have a data source, which is like a CDC data source, which generates abundance of data and continuously streaming data, right? Like IoT devices or some data like the database like Postgres, which keeps on generating using the logical replication, a whole CDC happening, right? So they send the message to the queuing system. From that queuing system, if you write it to the batch, so that's still, so there will be a lag. And with from loading the data, events getting generated to the time it gets loaded to the stage table, right? So that's where a Snowflake introduces Snowpipe streaming. And a Snowpipe streaming is something new, and which works that you don't have to, you define the Snowpipe, the concept of a Snowpipe outside a Snowflake system, right? So a Snowpipe streaming is a real-time data ingestion features in a Snowflake that allows you to continuously load data from external sources into Snowflake tables with minimal latency. It is designed to handle high volume, real-time data stream from sources like Apache Kafka, Amazon Kinesis, or custom application, or Google Pubs, for example, or your Redis, or even your local system, which can generate data. Like we have created in the demo or in the workshop, what we do in the tutorial, we have generated a data generator, which generates data, a CDC data. So like that. So what are the key features of the Snowpipe streaming, right? So it's a low latency ingestion. So data is available for querying within seconds of being received. So this is a difference, like the one of the difference, like streaming is real time, Snowpipe is a batch. A scalability automatically scales to handle varying data volume. Now, this is the features which comes in a Snowpipe as well, but Snowpipe, since it is a batch and it has a scalability in terms of you can have maximum of 10 clusters running a particular pipe. So it has its own. So you over here, you define your own, what do you say? You don't control, it's the sets outside the application of Snowflake data. You can scale as much as you want. It's fault tolerance. So ensure the data integrity, even in the case of failure, is secure. Simplified architecture, eliminate the need of intermediate staging areas. So in a Snowpipe, you used to have an external stage. That's where you place the file. It can be a GCP, is basically a cloud storage system where you store the file. And from there, it has to send a message, an SQS message or SNS message, a notification to the Snowpipe that the file has arrived, and then that file gets loaded into Snowflake. So if you look at like the difference between comparing the difference between a Snowpipe streaming and a Snowpipe, the form of data what gets loaded to a Snowpipe streaming is rows, whereas in a Snowpipe it's a file. So if your existing data pipeline generates files in blob storage, we recommend to use Snowpipe instead of API. So that's a pretty high definition what they have posted it on. A Snowpipe streaming uses a custom Java application code, basically a wrapper for a Snowflake to ingest SDK. So basically, they have written their own SDK to write the data to a Snowflake, whereas Snowpipe do not needs any third-party software requirement. So if there is a problem in terms of application software requirements and all, then a Snowpipe do not require it. Okay. A Snowpipe ensures that the way the data comes, gets loaded. So order insertion, so that's very crucial in that streaming data. If you have a requirement that as the event has occurred, you store the data in that way, both mostly in case of like a CDC data or an event occurring data like IoT device or fraud detection. As the event has happened, you need to load it as soon as possible, but also in the right order. Otherwise, you might detect that the row has been updated. If you don't store it in the right order, it has got an update first and insert after that. So that will lead to incorrect write. So that's why this streaming kind of solution is required. A Snowpipe do not support that. So if a batch of 100 files are sitting in Snowpipe, in this external state, Snowpipe do not ensure that it will load the files in the same order the way the files have arrived. It will just load the file. It can have any order in it. The next one is pretty much Snowflake a standard thing. You can see the Snowpipe streaming set into the file migration view, whereas for this you will see the load history view or copy history view function. Does not require a pipe object. Snowpipe streaming, the API writes record directly to the target table, whereas Snowpipe requires a pipe object that queues and loads the stage data into the target table. So to summarize this, traditional Snowpipe is a batch-oriented process, uses staging areas, it's a file-based, higher latency. A Snowpipe streaming is a real-time, direct ingestion, record-based, lower latency. So data is typically available within seconds from the time the event has occurred. Okay, moving further, how Snowpipe handles continuous ingestion, right? So what it does, like how it handles like continuous, what's the mechanism behind. So it does a direct data streaming, so receives the data directly from streaming sources without intermediate staging. So okay, micro batching groups incoming records into small batches for efficient processing. So that is taken care by the Snowpipe streaming services. End user do not have to batch the records or stream the records. Automatic scaling. So that's one of the scaling is the factor, right? Which we discussed initially. Dynamically adjust the resources to handle varying data volumes, varying data volumes. Exactly once semantic. It means that if an event has been sent, each record is processed only once, even in case of failure. So that is very much required in the any streaming services, that you don't process the same record twice. Otherwise, it will lead to a data duplication and all. Checkpointing, which is to maintain the ingestion state to resume from the last processed point after interruptions. So suppose in case, so basically the restartability. So if something has failed, you resume back from where it has last point where it has paused. Data validation performs a schema validation and type checking on incoming data. So that's also one of the things what a Snowpipe handles. Error handling manages and logs any ingestion errors for troubleshooting. So it has a not, I would say, top class logging mechanism, but it has a decent, humble logging mechanism to do it. Real-time monitoring provides metrics and alert for ingestion and performance and health. So this will help you to get a notification on Slack or something if you have integrated your notification mechanism. It will. So this approach allows Snowpipe streaming to have low latency, high throughput data ingestion process, while ensuring the data integrity and fault tolerance is maintained. So with this, what we are discussing, the question comes like, what is a Snowpipe API, right? We're talking about Snowpipe, but so how this works? So the Snowpipe API is a RESTful API that allows you to programmatically manage and control a Snowpipe operations. It provides a set of endpoints for creating, monitoring, and managing data ingestion pipelines. The key aspects of the Snowpipe API is pipe management. So basically, it will create the pipe, modify and delete a Snowpipe objects. Ingestion control, where it trigger the data ingestions and monitor its progress. Error handling, retrieve and manage any error that occurs during the ingestion. Metadata retrieval, get information about pipes, stage, and ingestion. So it's like a programmatical thing which helps a lot in terms of controlling the whole pipe management system. And it just sits outside. So that's the very like it's done everything programmatically and can be accessed using various programming languages. So this can be accessed, this whole API can be accessed Python, Java, Node.js, whatever language you prefer. Supports authentication using auth or key pair authentication. So in the current world of when the security is everything, it supports all of them with that. Uh, Enable automation of data ingestion workflows, allows integration with external tools and custom application. The Snowpipe API is particularly useful for building custom data ingestions, solutions automating pipeline management, and integrating a Snowflake data ingestion capabilities with existing data ecosystem. It is one of the tool which has come up and is shining in the shining armor of Snowflake that helps us to load a near real-time data into Snowflake with programmatical control, with setting it outside with high scalability and all. And we will have, if you look, we can work with Kafka or any of the streaming services. Earlier, what used to happen that you have a pipeline, which is a streaming pipeline. You write those data to the batch, to the external stage, and from there the data gets loaded. Now you don't have to write that consumer part. It's all written. So if you use the Snowpipe API, you will be simply able to plug that API to your Kafka and the consumer to write the data. So you just send the data to Snowpipe API, it will write the data to Snowflake. And it has a certain properties files. You need to fill up that, okay, this is the schema name, this is the database name, this is the user, this is the warehouse and whatnot. And it will just take care of data loading over there. And it is a serverless, so you don't have to worry about this. So with this, we like to proceed further to understand, or basically the setting up of the Snowpipe streaming itself. So like to have like how does this really work in the real time. So for the setting up the CDC simulator, which will you generate the data sets, I have used one of the Snowflake provided data generator, which uses what do you say? Yeah, it uses a Java language, Java library, which generates insert, update, and delete record for a set of tables. The reason why I've used that, because setting up Kafka and all would have taken will make it much more complex, not able to do a hands-on if people wants to do it. So in the link which I have shared over there in the agenda, over there, there is a section which goes for setting up a Snowpipe in a Snowflake. So for this, there is a simulator client. But before that, just wanted to walk through the prerequisites, what we need. So we need to create a Snowflake account. If you don't already have, you can sign up for a trial version, which comes for 30 days free for enterprise. We don't need the business critical for this features to test and validate it or to educate or even to do the labs. It comes for 30-day trial, no credit card or information is required. Just sign up with your email address, and it will come up. You will get a mail for your to the email about the validation authentication, and post that you can set up your username and password, and you will sign up like a account admin over there. You need to have a Java or JRE runtime environment on your laptop or desktop, and it should be Java version 11 or higher, and be able to download a SQL file or a zip file on the system, because the binary or the file which comes for the Java runtime, that's a zip file. We should have a Java program component, like we will need to run SSH keygen. And okay, so those will be the things to start. And we go with setting up the Snowpipe. So with this, I will start with this. So before even we go, so what I have done in the first, we need to download the simulator. That's what we will be doing. We download the simulator which is present on the once. So this is a simulator client. When you download it, it will create you a CDC simulator app.zip file. You need to unzip it. It will, for me, it gets downloaded in the download folder. That's why it's over there. Wherever you download it, that's where you have to do. Second thing you have to do it to log into your Snowflake account, which is something when you log in, it will be like an admin. So you'll get lots of hints and all. You can feel free to close them or minimize it boxes to because this guide will help you how to set those up. Okay. And the next is that you need to create a worksheet. I'm not sure if people are aware of it, but in order to create a aware of how to interact with Snowflake, but over here, if you click on, you will get plus sign, then you say SQL worksheet, and that should create and open up a new worksheet like that. This is basically any SQL editor over which we'll be using it further down the line. Now let's go and set up the Java client. I have set it up, but basically what we have to do is that we will be downloading the CDC simulator app. What I've done that I have unzipped this folder using unzip command, and that has created me this folder like CDC simulator, and then I went inside this directory. And once you are inside it, you can see a set of files present where it comes with both Windows and Mac or Linux kind of environments. Such file for the Mac or the Linux, bat file for Windows. If you have a Windows machine, the next step is to create a public key. And if you have a Java installed into your system, you will be able to create a public key over there, which is following this step, the command over here. I've already done it, so I won't be doing it, but I have this file. So if you type this, the first command, you should be getting an output like this. And when you give the second one, basically it will be writing the output of the generated public key to the RSA key file. And these are the two files which we get generated as part of this. We need to do the view the whole of the public key. And then we need this public key for the next step. That is step 6 when you go to the Snowflake. And that is first we need to create a role, which is if not exist. That's okay. I need to be an account admin for this, but I've executed it, but I will just take it here. Okay. Create or replace a user. So I have created a demo user for this, and then you alter the user and set that. So basically it is the key pair authentication what we are setting. So the key or the public key what we have got generated as part of our local installation, we place it over here. And that's it. The user is set now. The next step would be basically to go and edit the property files. And property files is something that's said, right? You have to define it outside of Snowflake that this is my username, this is the account, this is the, what do you say? This is the warehouse, this is the database, this is the schema where we need to load the data. So in this file over here, you will see that we have a snowflake.property files present over here. And if you open that file, it is with something like this. It has the user. So this will be the user which we have created over here. That is Snowpipe streaming demo user, which I have created. The role which is mapped to this particular user. So this is Snowpipe streaming role. That's what I have mapped it over here. The Snowpipe streaming demo. That's the role I have mapped it. The account name. So this is something which you can get it multiple places. One is over here. You can just go here and account. So you can fetch it either using that from this place, XC92487, or you can run a statement like this, given the command if you're comfortable with programming, and this will give you the current account name. The other identifier which we need to substitute is private key, which is already over there, which is downloaded in this particular folder at this point. RSA, the name of the, so that's where it happens, the key pair authentication or the handshake between the two systems from your local machine to the Snowflake cloud. And post that particular thing, once you have done that and your public key is set up, we are ready to, when you modify the property files, these are the information. So account identifier, whatever has been given double hash, you can see again, it requires an organization name, or account identifier. And account identifier is a combination of organization name plus account name. So account name was above, and then it is the organization name, which is jetq. So this one can be queried using this particular selector statement, which is given in the hint over there. Or you can run that, or you can come and see it over here. And if you get anything with this XC9, didn't like it. This one is in abundance. So you can copy it by clicking on this particular link. So this is a copy account identifier. That's where also it is present. So post doing that, getting the account identifier, you can close this property file. Rest all thing remains as it is. But as you see over here, we have defined the database name. So whatever the database name you set it up, you can set it over here. The schema I have defined engineering ANG, but you can define your own. So this is where you control. We don't do anything in a Snowflake in terms of giving that Snowpipe. We don't create a Snowpipe in a Snowflake in this Snowpipe streaming, where you say that copy data into this particular table. You define everything through this property files over there. For this demo, for this, the file generator is generating a maximum of 1 million rows over here. Show key value false, debug false, and channel one. So there, any Kafka, if you've been aware of the queuing service, they work with the channel. So every table has, for this streaming services, we have for one table in the source, we have one channel. So any data which is coming from to this particular channel one will be writing to CDC streaming table. You can have multiple channels writing data to multiple different table. Now, moving back to the demo, that we go and proceed further, and then we create a role with for this lab to grant permission. So we can do it with use role account admin, set my current user current role to the Snowpipe demo, which want to create. So basically, I will say create a role. If not exists a Snowpipe demo, grant role Snowpipe demo to the identifier to my name. That is $my name is my account, and it will be in, for your case, it will be your individual account name over there, and then grant the permission as required permission over there. Then at the last, we go ahead and create the warehouse, a dedicated warehouse, which will be required. So once you do the create or replace warehouse, this one, grant all privileges of warehouse to the Snowpipe demo, grant usage of this. And then if you look at this, you will be able to see that there is already a Snowpipe warehouse started, is extra small, minimum cluster one, max one. You can set this up to max 10. That's what it goes for. But we are for this demo, small, extra small, and we get just $400 credit. So use it wisely. Otherwise, if you finish it off, then it will start asking for your credit card, or you have to shut down your instance, or it will shut it down by itself. So moving to next, we need to proceed further and create the database where we are. So remember the property files. This is the database name what we have given over there. So I need to go ahead and create the same database over here. Okay. So you create the warehouse, you use the database, this grant ownership on this public schema to Snowpipe demo. What I have done that I have revoked all the permission from the account admin, because initially when I created the database, I was the account admin over here, and that's what has set it up. So I have revoked all the privileges and then granted all the ownership on the database to the Snowpipe demo role, which I have created. And I have, so if you look on the top over here on this section at this place, uh, so this part over here, you can see that the Snowpipe demo, that is the role, a Snowpipe demo warehouse, that's the warehouse. Then over here, you can see the context for this particular worksheet is that Snowpipe streaming demo DB is the schema, is the database, and public is the schema at this point of time. Okay, moving further on this, making a progress further. Once you have granted all the permissions, you will be able to see this database over here, and you will be able to see the schemas over here. Yeah. Drop this table, so fine. Proceeding further and providing the necessary grant, we proceeded further. We again use the role now, the Snowpipe demo, use the warehouse this, setting up all the context is already set. We don't have to worry. Further grant uses on DB to Snowpipe streaming demo. And this is the role which is used by the Snowpipe streaming to connect and write to. Then we create the schema. Engineering in this case already exists. We can change it. We can write it to any other database, other schema, and that's what it will work. And then we are saying that use over here, if you see it is written public, but once we say use this, it becomes engineering. So now the context is set to be otherwise, every time we execute the command, we have to give the full name, like write with the database name, schema name, and then to do the object. Proceeding further, it will be grant usage, grant the usage on the public, grant usage to the role public on the schema too. And with this set, we need to create the staging table, or the table which is under the schema where the data lands. So basically what we are doing, the output which gets generated from the simulator, it's a JSON rows and just one column. So we call in a Snowflake, we call it a variant data type. So I created just a table with a variant data type and given a grant insert on permission of insert. And if we query the table, we just get nothing, and there is no record present at this point of time. Now we need to generate the, so right now what is set is that we have a table which is an empty. We have a Snowflake properties, which is set that from this simulator using this public key with pair handshaking, write this data to this particular database on this table using the role a Snowpipe streaming demo, and over there you have from the data will send to the channel one, and that channel will write data to CDC streaming table. So for the next, what we'll have to do is that we need to generate the data set. So over here, we have a file called test.sh, which is responsible to generate the data. So if before that, at this point of time, we need to test that the whole the whole synchronization between my data generator, the Java connection to Snowflake is working. So if this test.sh, which is basically calling a validation jar under the hood, CDC simulator client jar, ensures that the connectivity is successful and we have a proper connection. So if I run the streaming application, it should be able to generate the data for me. So run max.sh is responsible to generate a data and push it to the table. It should take close to 5 to 6 seconds. So fine. It says 1 million rows has been sent and returned total, including confirmation. So it took 8 seconds, 0.3 seconds to write 1 million row into the table. So if I look at the record count at select count star, it says that 1 million rows are there. And if I do at the select star, I can see the object that says that action is insert, delete, update will be also there. So update over there. Now, since it is a semi-structured data with a Snowflake, like you can query out using the semi-structured mechanism, the parsing of the Snowflake, and you could be able to see that fetch certain values within the same from that record. Or you can read form the whole data set from the CDC streaming to know that the transaction type is insert like this. So you can see that this is something which is an insert record after so over this. This will be useful because when we move towards the dynamic table creation, this kind of this queries will be, you will use it further in order to simulate towards the dynamic table thing. Now coming back to our, so with this, will this be still there like this? Let me see if I can. So what we saw in this demo, if you follow down on this, is that Snowpipe streaming is done, the pipeline is there, the data can get pushed without creating a SNS object and SQS mechanism to notify Snowpipe to load the data into the table. Within a fraction of seconds, like 8 seconds for 1 million events from local to a cloud sitting in Frankfurt, still a very powerful tool in terms to use it for this. And with this, we come up with the how do we set up a Snowpipe, that particular topic as an end. I will stop here and check that if people are interested for a break, or shall we proceed further on this? Any suggestions, guys? Okay, so let's proceed further on this. That's thing which you've got. So we'll proceed further on this. So with this, moving to the next segment of this, the dynamic tables. And if you look at the screen, what does it gives the understanding? It says that there is a certain table ABC and there is a dynamic. So as the name simplifies, dynamic tables is a Snowflake are automatically refreshed that simplify the creation and maintenance of data pipeline. They allow you to define transformation on your source that's on the table A, B, or C, and that are automatically kept up to date as a new data arrives. So you have a table which is combination of two tables, and if a data arrives in either one of them, you still want to keep your dynamic table up to date over that side. Yeah, that's the final table as updated. So this will help. So the key features when we look around dynamic table is defined with SQL. So you can create a dynamic table using a SQL query that will specify how to transform a data from one or more sources. This is something very important to understand because multiple materialized view and dynamic tables, when it comes to understanding, they all auto refresh, right? But materialized view work just with one table, whereas dynamic table works with more than one table. It has an automatic refresh, so Snowflake automatically refreshes the dynamic table based on changes in the underlying data sources. This means the data in the dynamic table is always consistent with the latest information. So any of the data sets change between A, B, or C, dynamic table A will get refreshed if the data in table A or B gets changed. The dynamic table B get refreshed when data in B or C gets refreshed. So although they're defined by a query, dynamic table stores the result of that query. This makes accessing the transformed data very efficient, right? Incremental updates. So it's just another aspect of the features of the dynamic table that a Snowflake intelligently analyze the query and often only update the parts of dynamic tables affected by changes the source data, making refresh fast. So we don't have to refresh the full data sets. So with this, we briefly wanted to touch the difference between the materialized view and dynamic table, right? Materialized views are designed to improve query performance transparently. Dynamic tables are designed to build multi-level data pipeline. So materialized view is just that if you add a cluster on a particular table, it's a very big table. And if you have added a cluster key, so materialized view is the way where you say that I have a cluster keys, certain filtration, and it will keep updating as soon as the data changes. But it's worked with one table. Whereas dynamic table can be used as a multi-level data pipeline. It means you have one table sitting on 4 or 5 table joins, and that's you don't want to manually go and refresh it. As soon as the data lands in one of those tables, the target final table gets refreshed automatically. So a materialized view can only use a single base table. As said at the starting, materialized view is just one table. Dynamic table can compute complex queries, including one with joins and unions. So that's something which is very useful when it comes to this particular information. Data access throughout materialized view is always current. If a DML operation changes in the data in the base table, a Snowflake either update the materialized view or uses the updated data from the base table. Whereas in dynamic table, the data is current up to the target lag time for that. So it's always up to date. As soon as the dynamic table maintenance and refresh are automatically managed, the separate compute services is there sitting under the hood, which including the refresh logic, along with the compute for any updates, typically at additional cost. So you need to understand one question, one thing very smartly. Don't implement dynamic table for each and every object, because there will be a cost associated with it for the refresh. Don't put a dynamic table for like a table with 4 or 5 joins, where each of the tables are getting refreshed, like getting data, like streaming data continuously. Because in that case, it won't be, it will increase your cost. So you have to be very much pragmatic and understand to see the use case, what it is trying to solve. Otherwise, the cost of Snowflake compute, since it is a serverless compute, it will be just go high. The coming to the key benefits for the real-time transformation. So if we look back, right, the dynamic tables, what does it bring to the thing? So it is like it makes the real-time transformation as soon as the data arrives, and I have a downstream tables which is dependent on that. A real-time analytics has to be done on that. fraud detection kind of. We'll talk about the certain use cases later, but that's it helps you so why is the real-time information? What's the key benefit, right? So it helps to make a improved decision making. A real-time transformation provides like up to date data, enabling businesses to make informed decisions both based on the latest information. This is crucial in dynamic environment where condition changes rapidly, like fraud detection, uh, uh, IoT device sending events over there, or the CDC event happening from our database. Enhanced customer experience. By having access to real-time data, business can personalize customer interaction, offer timely support, proactive address issues. This leads to increased customer satisfaction and loyalty. Right. Increase operational efficiencies. Real-time data allows for immediate identification of operational bottleneck. Right. If you get a data like you have a system which is uh, started sending less data all of a sudden, and you have a real-time streaming pipe, and you can detect just by that if there is an issue happening, something has gone wrong because of which this all of a sudden the traffic is going down or the data is coming incorrect. So that's the aspect of monitoring, but so I'm not putting that into this transformation logic. But inefficiency and emerging. So if anything is happening, like there is a negative sentiments happening about a particular product or particular features, with real-time pipeline, you will be able to know much more immediately that this is a sentiment of the customer. You can take immediate actions on that. Faster time to insight. So real-time transformation eliminate delays in data processing and analysis. This means businesses can gain insight from their data much faster, accelerating innovation and enabling them to respond quickly to market changes. Greater agility and responsiveness. Real-time data empowers businesses to be more agile and responsive to changing market conditions, customer needs, and competitive pressures. This flexibility is essential for staying ahead in today's dynamic business environment. So, how dependency tracking and update works in the dynamic table? So, we'll understand that, okay, what are the key benefits of the real-time transformation, but how the dynamic table dependency tracking like works, or how does it understand that I need to update the tables frequently. So this we can split it into two parts. One is dependency tracking, that is automatic detection. Under this, when you create a dynamic table using a SQL query, a Snowflake automatically analyzes the query to identify all the tables or other dynamic table it depends on. So this creates a dependency graph, which we'll see further on the Snowflake UI itself. And then the direct and indirect dependencies. A Snowflake tracks both direct dependencies, the table directly referenced in the query, and indirect dependency table that those table depends on, and so on. This ensures that any changes relevant to the dynamic tables are captured. And then there is the second one is like this is the automatic detection, direct or indirect dependency. Then it comes with the update mechanism. So automatic detection, sorry, automatic detection, when you create a dynamic table using a SQL query, a Snowflake or automatically detects it. Now, change detection. The change detection is something which makes a Snowflake continuously monitor the source table for any changes, insert, updates, or delete. It uses various techniques to detect these changes efficiently, often leveraging its internal metadata and change tracking mechanism. A dependency-based refresh. So when a change is detected in a source table, a Snowflake triggers a refresh for all the dynamic tables that depends on it, directly or indirectly. Incremental updates, where possible, a Snowflake performs incremental updates. This means it analyzes the changes in the source table and only updates the specific row or partitions in the dynamic table. Full refreshes in some cases, such as when there is a complex transformation or schema changes in the source tables, Snowflake might perform a full refresh of dynamic table. And this is another app feature called target lag, where you as a user can define that this is the lag my table should be having. So when you create a dynamic table, you define the lag that should be 1 minute, the table has to refresh, or every 10 minutes, the table has to refresh. It will refresh irrespective of data being changed downstream, it will just refresh by itself. This defines how fresh the data needs to be. A Snowflake will schedule a refresh based on this target lag to ensure the data is dynamically in the dynamic table stays within the desired freshness window. So for example, if you see, you have these table raw orders or customer info or dynamic order summary. You have a combination of three tables. And you have a dynamic table that joins the dynamic order summary, which joins customer and the raw order information. If a new or raw order is getting generated, the Snowflake will detect the change in the raw order, the first table itself, and recognize that dynamic order summary, the dependent table. If you have a combination of, I draw it, I think that would be. So let's do it over here. So you have a table which is have a like raw order table, and on this there is another table which is customer info, for example. And this collectively creates a dynamic table, which is raw order customer info. And what happens that if a row changes to this table, raw table, or if a row changes to the customer table, a Snowflake detects by itself that it needs to refresh this particular raw order. The third table sitting over. Let's give a number 1, if it is just for easiness. The table third needs to be refreshed because there is an entry into the table 1, or there is a row has been changed in table 1 or 2, and a Snowflake will automatically detect. So if you have said that every 2 minutes, the target lag, then every 2 minutes, the Snowflake will go and refresh the particular table. And it will, at that point of time, it will check that table 1 has a change or a table 2 has a change. And based on that, it will go and refresh the downstream. So these are the ways where the way we do it. So how the dependency is being detected. Now let's move to the demo where we go and create the dynamic table in Snowflake. So as we saw in the example above, that this is the CDC streaming we are capturing. So over here, I'm creating a dynamic table, which is responsible for which has all the partitioned column, all the columns and the denormalized, or basically the JSON, read the JSON file, split it into row and a column format, so we can easily read it in a structured data format. And I basically interested in these two types of record content, limit orders and prod. So what I have said, I created a dynamic table over here, which says that the lag of 1 minute, use the warehouse, Snowpipe demo warehouse, and creating this dynamic table just to say that I pick up all the rows which has this content. And if I run this query now, it picked up like my source table had 1 million rows, but it has picked up 500K, 542.7 rows entry inside it. So now my dynamic table is created, but this is the static data, right? The table, if you click on the left side, you can see a dynamic table over here created, but this is in a static data set. We need to play with, show that we talked about a Snowpipe streaming. So how do we collectively combine these two together? So for this to happen, we'll proceed further and go and run this particular command in this file, which is run. So what this does, this particular shell script, what it is doing, that it is generating in a slowly changing dimension. It is creating a regularly insert update. It's just not stopping at 1 million. It is keep on updating, inserting new rules. So if, and on very slowly, it's just this number will keep on running. And if we look on the source table, what we have created over here, the record count has started increasing. So it was 1 million, now it has gone to 115, 174, and keeps adding. Whereas the record count in my table was 542,257, so 542K, and still, and it has just now started increasing. So if I see the rows are every minute, so it is like 415, 59, so 416, 59. If I run it like in a minute, I should get more rows count present over there. And that's what is this. The dynamic table is meant that the records are getting generated at the source. Snowpipe is streaming the data, putting into the raw table, and then the dynamic table sitting on top of it, which is just auto refreshing by itself as the new data sets comes in. You can do a much more complex thing on top of it. You can do for further filtration, run a couple of joins. This is a very simple demo on created for this one. Just to say that this is how on a very high level look like, but there is much more complex things which can be done on this. If you have just an example, like if you have a pipeline which is running from, we have a requirement, had a requirement that as soon as the pipeline data comes from Salesforce, we need to refresh our pipeline immediately. So we run our pipeline of the Salesforce extraction on Airflow. So from Airflow on a stitch, and from a stitch, it was not possible to make a call so smoothly to the Airflow to run the DBT model for downstream. So what the solution, what we thought of, that we schedule this Snowpipe dynamic table to refresh as soon as the data changes for it. So it will refresh only when the new data. So I didn't had a dependency on a stitch. A stitch completed a task like every 4 hours, it done a refresh. And as soon as the refresh happens, every 30 minutes, this task runs, and it's for the dynamic table refresh, and it picks up the new record and processes it downstream. If there is no new record change, it do not refreshes. So it do not refresh all the DBT tables, all the downstream model which do not gets new record. It only refreshes the tables which is required, which has the record change modification. So this is one of the use cases what we have solved in practically at this point at this. So with this, if we see the record counts are keep on increasing, the number of rows are also getting streamed using this Snowpipe, and the volume is going higher and higher. So I will just stop this generator. So for this, and we'll go back to. So next is monitoring of dynamic table. So in order to monitor the dynamic table, how do you see it? So over here, if you can do it like programmatically, or you can do it over here. If you go and look at the refresh history of this table, I can't see anything because on the left-hand side, you can see that at the bottom left corner, account admin, I need to switch my role to Snowpipe demo, and then I need to select a warehouse. And then I should be able to see all the metrics which is running over here. On the graph sections, you can see the dependency that this is the first CDC streaming table, that's the raw table, and then the dependency is set to the limit order current date table over here. You can view the data, what's present on this table, columns details, and other information which is required. That's on the monitoring front of the tables. We again want to recapture and show the something. So this the overall architecture looks like in terms of combining the Snowpipe and the dynamic table. So we discussed, deep dived into the Snowpipe streaming and then the dynamic table. This is the whole collective pipeline looks like. This is something which we are working effectively at this point of time to consume data from Postgres, write it to a Kafka queue or MySQL database, any of the database of your choice, or the use case what you have. Consume the data from there, write it to the queue, a streaming service, and that streaming service is just responsible to just connect write it to the Snowflake Snowpipe streaming service, and which is responsible, the streaming channel is responsible to write to the table, and the downstream table gets filtered data as so like every 10 minutes or 5 minutes what we define for. The benefit, it removes that not to maintain any additional Snowpipe or any objects. I get to ensure that my data correctness, that the insert is coming before update and then the delete is coming after everything is done. It's ensured that. So Snowpipe is streaming in just the raw data in the real time. A dynamic table automatically transform and aggregate those data sets. Analyst application can query the latest result with high performance. So this combination enables truly real-time analytics without complexity of traditional ETL process what we have. Right. So best practices for Snowpipe streaming and dynamic table. So this one we have written in the notes as well on the README page. Plus also over here, like there is use of dynamic tables, the best practices. It should be in a strategic use. Dynamic tables are ideal for data that needs frequent refreshes and where transformation are relatively straightforward. For complex transformation using streams and tasks, you consider using streams and tasks for more control. Because the cost is also, nothing comes for free. You will end up paying a lot if you don't optimize query performance. Okay, the performance of your dynamic table depends on the underlying query. Use appropriate indexing, partitioning, clustering strategies of the source table to optimize query performance. Target lag. Don't choose set something which is like 30 seconds. It will not give because the data is still getting consumed. You won't get the value out of it. Only the cost will increase. Okay. Keep an eye on the performance, so monitor the performance, refresh history of your dynamic data. Look for long running refreshness or frequent full refreshes, because you will come to know from there that it is a full refresh or just, and which one is taking. So keep always monitor it. Otherwise, everything in this cloud or the SaaS platform goes for a cost over there. Minimize your dependency. So while dynamic tables can depend on the other dynamic table, try to minimize deep chain dependency because this make it harder to track updates and troubleshoot issues. Keep it simple. Don't make it over. If it is overly complex, multiple dynamic tables like make it 50 or 100, it will be too challenging in order to investigate and debug it, right? For a Snowpipe streaming, the best practice is efficient client configuration. Use fewer Snowpipe streaming clients that writes more data per second to optimize cost. Aggregate data from multiple sources before sending it to Snowflake. So that's one of use it. So collect it before, then put it to the pipe. Don't push every row by row, that it will become a much more costly process. Aggregate it, compress it, push it based on the use cases again. Multiple channels, utilize multiple channel per client to improve performance without increasing client cost. Okay. Automatic clustering. So enable automatic clustering on tables used by Snowpipe. So Snowpipe, when the streaming data sets comes in, the volume is like we see a traffic at this point of time like 500 GB a day coming in. And if we keep dumping that data to a table, if there is no clustering, the performance goes very bad. So even though we add a dynamic table on top of it, it will not make a sense because the clustering is so bad. It is so try to use automatic clustering and those things. Data validation checks within your streaming pipeline ensure to have error handling, security. Secure your Snowpipe streaming clients and connection with using appropriate authentication or authorization mechanism. Don't so have a key value pair or auth mechanism as recommended by them. End-to-end monitoring, monitor the entire data pipeline from sources to dynamic table to identify bottlenecks. So connectively, the best practices for combine of the both Snowpipe streaming and dynamic table is to monitor the entire data pipeline from data sources to identify bottlenecks and plan for schema changes in your data. So that's also is one thing which is schema evaluation, which is always keep changes. So streaming setup adapts to these changes gracefully. And in terms of use cases, we talk about like 4 different use cases. Real-time analytics dashboard. Imagine an e-commerce company that wants to track website traffic, user behavior, and sales in real time to monitor performance and identity trends. I think this solution of combination of a Snowpipe streaming, so Snowpipe streaming in just a raw click stream data and order events. Dynamic tables aggregate and transform this data into key metrics like page views, conversion rates, revenue by product that are used to populate real-time dashboards for business analysts and executive. Second use cases which comes seen people using is for fraud detection. A financial institution, a scenario which a financial institution needs to detect fraudulent transaction as they happens to minimize losses and protect customers. This combination can help in ingest transaction in real time and dynamic table apply business rules and machine learning model to identify suspicious patterns and flag potential fraudulent. Personalized recommendation, IoT device monitoring, supply chain optimization. So there are multiple places, there's multiple use cases where this can become, it can be useful. With this, I would like to conclude the whole session. What we discussed and what we covered, just wanted to cover it back. We discussed about what is a Snowflake, a very high level Snowflake architecture, our different Snowpipe streaming, what was a Snowpipe earlier and what they have changed to Snowpipe streaming, the Snowpipe API, dynamic table, how it is being created, what's the benefit of that, how a combination of dynamic table plus a Snowpipe streaming help us to build a real-time data pipeline for highly efficient analytics, and what are the best practices to do for. What next on this? It's pretty much simple. I've already shared this study material on this on the website. And this is about me. If you want to look up me, find me, ping me, or just ask me anything, scan the QR code. I'm highly available on LinkedIn, and any question or answer you have, I'm there to circle back. And with this, I would like to conclude the tutorials. Thank you, everyone, and I can open the floor for questions.
There is a question in a Q&A section, if you can read it.
Yeah, sure. Going there. Why I can't see that? Once. I'm just checking that. It's coming. So the question is from Bilal. What cost measurement can be taken for a Snowflake enterprise account? Let's say a big warehouse is being used. is this a good idea to aggregate in Postgres and then transfer the data to SF, or should we first transfer the data into SF and then aggregate it? So this is something, Bilal, we are also solving. So this tightly closely relates to this. If you are bringing data from Postgres, a real time depends upon the use cases. If you have a real time streaming data coming up from Postgres, you can do it in batch. So when we do it in real time streaming, like data coming from logical decoded message coming from the replication, we put it in batch in the producer part when we decode the message and then pass that data using a snow. So I'm not using at this. So we are using a Snowpipe streaming, but not for Postgres at this point of time. So putting it into Snowflake will be one-to-one mapping. Then you can aggregate it over here. But if on the so, but if you need to increase, if you really want to reduce your cost of Snowflake, you would like to do as much computation as possible at the source side. But if you have to do like lots of, if you have a performance bottleneck at source where you have like a read lock kind of constraint that your query should run maximum for like 10 seconds, that's what we have that in the production system. I think the option is to bring it to Snowflake, write efficient queries, because one-to-one dumping do not work in the Snowflake. We need to optimize our query using cluster keys, auto clustering, because that helps a lot in order to increase the performance of the query. So I would suggest for the cost for enterprise account or any account, I think the pricing is just higher if we go for move further. Uh, if you want to reduce, if you have a flexibility to run an aggregation on the source, then run it over there, because over there in the Postgres, you have a fixed cost. But if you have a time limitation or a bottleneck, like you have to only finish the query in 10 seconds, then I think you'll have to bring the data to Snowflake, store it efficiently, like using cluster key and all, and then you can put like if the data is like one-to-one mapping, you can just put a materialized view. But if you want the data to have very high latency, low latency, like within a second, within a minute, it has to refresh, then you can put a dynamic table over there. Does it answer your question, Bilal? Okay. Thank you. Any other questions? Okay, there is another question over there. Just sorry, my kid came in. So, what are the main difference between dynamic tables and DBT? Okay, DBT is a database transformation tool. That's what I'd say. So, it's a transformation. DBT and dynamic tables are DBT supports dynamic tables. So, there are different types of tables in Snowflake, like permanent table, transient table, temporary table. There is an external table which relies on the external data source, and then we have this dynamic table, which is the fifth one. DBT is a tool which helps you to do the transformation. So if in a DBT data build tool, they call it, that you define that this particular data model or a table is a dynamic table, then it will create, when it runs the DBT model on it, it will go and create the table in a Snowflake as a dynamic table. It will take those metadata like lag time, the warehouse, and all those things, and it will create that particular thing for there. So these two things are, you can use either you can remove your dependency from DBT, and if you have very simple complex very simple table or a join which you wants to build into one particular table, you don't have to rely on a DBT to run. You can just set it up to run on a Snowflake, and it will take care by the dynamic table. You can create that dynamic table using DBT as well. So that's a difference. So both are two different things uh, used for. Both does the transformation on the node. Dynamic table also does the transformation. DBT also does the transformation. But DBT is the tool where using which you can create a transform dynamic tables within a Snowflake.